So my example, next example is, the question is that we want to find the equation of tangent line to the curve C, and the curve C is given by r of t is equal to t sine ti plus t cosine tj plus tk at the point t is equal to pi by 2. So we to find the equation of tangent line, we need a vector parallel to the line of the point. So first we find the vector. That's my r dash of t. R dash of t, we use the product rule. They having t sine t, so give me first function derivative, second t cosine t plus derivative first is t is 1, we having sine t I, then the derivative of t cosine t is minus t sine t, then plus cosine t j and plus k, because derivative of t is 1. We want to find r dash of t at the point pi by 2, and we want to find the point also at the point. First I find the vector, unit vector, tangent vector at t is equal to pi by 2. I need the values of cosine pi by 2, and cosine pi by 2 is 0, and sine pi by 2 is 1. We use these values to write our values. So having here that give me r dash of pi by 2 is equal to, so sine pi by 2 is 1, we get here I, because cosine pi by 2 is 0, cosine pi by 2 is 0, sine pi by 2 is 1, and here is minus pi by 2 j and plus k. So this is here my result 1, that gives me the vectors. Then I want to find the point at the curve at the value of the point of the curve at pi by 2. So substitute here r pi by 2. R pi by 2 will give me the point. So that r by 2 will be f of t. We having here x is equal to f of t. So this will I take as a point. My point is t is pi by 2 and sine pi by 2 is 1. So get here pi by 2. My y is t cosine cosine pi by 2 is 0. So my y is equal to 0 and my z is equal to pi by 2. So my point at t equal to pi by 2, I just write here, this is my point. Now I take from here, substituting r equal to pi by 2, I get here the point pi by 2, 0 and pi by 2. So this is my number 2. So I have the point, I have the vector, so I can write equation of the parametric equation of the tangent line to the curve. So I can write here using this 1 and 2, using equation 1 and 2, equation of tangent line, and we are taking here parametric form. We can write here this equal to x0 plus a1t, a1 is 1, y equal to y0, y0 is 0 minus pi by 2, minus here we are having here minus pi by 2 into t, and we having here this is z equal to pi by 2, this is my point, z0 plus t, where t you have seen is bigger than or equal to 0, because the domain we have defined this one. So that gives me the parametric equation of the line as we required. So we have in this example. So I'm going to give you another example for finding the parametric equation of the tangent line. We are given here the parametric form of the vector value function. We're having x is equal to 2 cube minus 1, y equal to minus 5t square plus 3, and z equal to 8t plus 2. And we want to find the equation of tangent line at the point that's 1, minus 2 and 10. Here where t is not given. In the last example t was given, and from given t we were able to find the point, and we want to find the vector. So write the equation of the line. We need two things. We need a point and we need a vector parallel to the line. So here the point is given to us. We want to find the vector, and vector is our r dash of t. So r of t we write here, this is equal to 2t cube minus 1 minus 5t square plus 3 and 8t plus 2, and we take the derivative of this one. We have 5t cube, that gives me 6t square, and then derivative of 1 is 0, and here is minus 5t square, derivative will be minus 10t, and derivative 3 is 0, and we get here 8t plus 2, derivative will be 8. Now we want to find t. So to find t, we put the value of the function f of t or g of t or h of t for the corresponding value in the point. I take the value of f of t and put equal to the point, that is 2t cube minus 1 equal to 1. I solve this one, I get here 2 cube is equal to 2 and t cube is equal to 1. We take cube root of that one, t is equal to 1. We have only one real root in this case, only when we have the cubic equation, so that is equal to 1. To get the value of t equal to 1, we find r dash of 1, put here t equal to 1. I get the value of r dash, that is minus 6, minus 10 and 8. This is my vector and this is my tangent to the curve. Now I get a tangent to the curve and I have the point. So I can write an equation of a line tangent to the curve. So that will, my parametric equation will be x equal to x0, x0 is 1, and this is equal to plus a1 t, a1 is 6, y equal to y0, y0 is minus 2, a2 t, a2 is minus 10 t, and z equal to z0 plus a3 t, z0 is 10, and a3 is 8. That's my component vector component, and I get here, this is by parametric equation of the tangent of line, not only the line, tangent line passing through the point. So that's my equation that I found it. This is my, not only the line, this is my tangent line, and we have this. Now next is we want to find the rules for the derivative, how we want to differentiate it. So differentiation rule, we having two functions u and v, and they are differentiable function, vector value functions. So we have the first rule is sum, that we having derivative of u of t plus v of t, that's equal to du by dt plus dv by dt. Now if I am having number 2, c is a scalar and we have ut, then we know if you take the product rule, even then the derivative of scalar will be 0 if we take the product. But if you take c as a constant, we take t c out of the derivative and we get du by dt. Now next is the product of the function f of t is any for a differentiable real value function, not the vector value function, and we have u of t is a vector value function. We want to differentiate, then we are going to find the derivative of product rule, the first function derivative of second plus second function derivative of first. So we take derivative of first function, that is f of t, into second function u of t plus first function derivative of second function du by dt. Now next is we are going to have the dot product and we having the cross product, and we try to find the rule for finding the derivative in this case when we having the dot product and cross product of two functions. So we will retain the dot and the cross, and especially in cross product, you know, if we take a cross b and we change the position of a and b, then become minus b cross a, so that the position will not be changed. In dot product you can change the position, but anyhow we retain the position, and we have first function derivative second, that u of t dot dv by dt, and plus second derivative of first function du by dt into dv by dt. In case of cross product, we must be very careful, we must not change the position, and we get here u of t cross dv by dt plus du by t cross v. The last one is that we can find the chain rule, that's here as before, we can have the derivative of u dash f of t, and then derivative of f of t is, we get here this, we can write this one also is equal to u dash of f of t, and then we having f of t, and then we having derivative of f of t is f dash of t, both way we can write. So this is the rules we can apply to find our derivative. Here we are having an example, we are having here the vector value function and r of t, that's equal to ti plus 2j plus t square k, and our u of t is ti minus t square j plus t cube k. We want to find the derivative of the function when we dot product of r of t dot u of t. You can apply the formula, or if you are smart enough you can just find the dot product and then we can apply it, but we are going to use the formula. Our formula is that we are having here du by dt, d by dt of the dot product r of t into u of t. R of t is the vector value function, u of t is a vector value function. We are having r of t dot u dash of t, derivative of u of t, plus r dash of t into u of t. That's our dot product here, we must be very careful. This is our dot product, not a simple multiplication. So I can write this equal to that my d by dt of this function r of t into u of t. I can have here the dot product in this case. Here we can write this equal to r of t. R of t is what? R of t is ti plus 2j plus t square k. We take the dot product of this one with du by dt. The vector is here ti minus t square j plus t cube k. Then we add this one, and we have the next term is plus d by dt of our r of t. So I write here the derivative of this one. My r of t is ti plus 2j plus t square k. We take the dot product of this one with our u of t. Our u of t is ti minus t square j plus t cube k. Here k is missing. We write here k also. Now we take the derivative of this one. We can find here the vector given to me is ti plus 2j plus t. We're having it not clear to me. Just we see t square k, and then we take the dot product with the derivative of this one. This one is derivative of t is 1 I plus minus 2 tj plus 3 t square k. This du by dt. Plus now we take the derivative of our vectorial function r of t. We get here I plus 0j because derivative of 2 is 0 plus 2 tk as dot product with the vector ti minus t square j plus t cube k. So now we go further and we take the dot product by using our formula that a dot b is a1 b1 plus a2 b2 plus a3 b3.